In this problem, a bucket that weighs 5 pounds and a rope of negligible weight are used to draw water from a well that is 90 feet deep. The bucket is filled with 36 pounds of water and is pulled up at a rate of 2.5 feet per second, but water leaks out of the hole in the bucket at a rate of 0.25 pounds per second. Find the work done in pulling the bucket to the top of the well. So the first thing that we need to do is decide what our variable is going to represent. So let's let x represent the amount of rope that is hanging down. Okay, so if that's the case, then we can find an equation that would represent the amount of force that is pushing down by the bucket and the water. But first we'll need to know how much the water weighs at any point during the travel of the bucket. So we'll do that by doing unit conversions with what we're given. We're given that we have a leakage rate of 0.25 pounds per second and a lift rate of 2.5 feet per second. So if we multiply by 0.25 pounds per second and seconds per 2.5 feet, we wind up with the units that we want, which is 0.1 pounds per feet. That's how quickly the water's leaking. Now, looking at a graph of that leakage, we start at time 0 or at feet 0, if feet is our x-axis. So before we ever start pulling it up, there is a weight of 36, but it leaks at a rate of 0.1 pounds per foot, which means that the amount of force pushing down is going to decrease. So this is the slope. It's a constant rate. So the slope of this line then is negative 0.1. And then we can find an equation for the amount of force that the bucket and water are applying to the rope in terms of the distance. So just in slope-intercept form. So that's the force. But remember that we also have the weight of the bucket. So we have minus 0.1x plus 36 plus 5 for the weight of the bucket. And that is going to give us the actual amount of weight that is being applied to the rope, so the total force. In order to get a unit of work then, we'll need to multiply that force times a distance. So if we think about moving a slice, a distance of delta x, and then do that infinitely many times, then we would get the total work that's being done. So our integral would be 0 to 90 minus 0.1x plus 41 dx.